Alrighty, here we are with 3.3 day 2, where our objective is to graph a solution to a set of inequalities, specifically 2. Okay, let's dive right into an example. Alright, just like 3.3 day 1, okay, how we graph each one of these individually will be no different. Okay, we just have to essentially do what we do to graph an inequality twice. Okay, to get these on the graph, we're gonna treat them separately. Okay, so let's zoom in on our graph. Let's take a look at y is greater than or equal to x minus 2. Okay, y-intercept is right down here at negative 2, and the slope to this graph is 1, so notice I'm going up 1 over 1. Plotting all these points that go in a straight line, forming the line y equals x minus 2. Okay. Now it was greater than or equal to, so I am going to connect all of these with a solid line. Okay. There it is. And if I was doing one inequality, this would be the point where I would shade it. Now it's a greater than. We'll just zoom back out for a second. Oops, too far. It's a greater than, so I'm going to shade above, which would be over there. And now I'm not actually going to shade yet. I don't want to, because I still got to graph this, and then I want to shade the areas that are solutions to both. So y equals 4 would be 1, 2, 3, 4 units up. Notice I'm using a dashed line because it was a strictly less than. Okay, which means I would shade underneath, but notice again I haven't shaded yet. All right. Now, I want to shade the area that represents solutions to both. Okay? So I'm shading in this area right here where the arrows are pointing towards each other. Okay? Notice this solution area is above the blue line and below the red. So it satisfies both graphs. All right? So there would be my area that are those points are solutions to both of those inequalities. Okay? All right, here's another one. Line with a quadratic. Okay. Linear equation with a quadratic. Let's go and let's graph this one first. Let's leave the quadratic to deal with second. I'm going to graph the line y equals x plus 2. Okay, y-intercept is 2. Slope is 1. Okay, so notice I mark the y-intercept. And now I'm using the fact that the slope is 1 to plot a bunch more points. Going down this way. Okay. Now this was a strictly, I think it was greater than. Strictly greater than, which means I'm not including the points that are on that line as solutions. So I mark it with a dashed line. It is strictly greater than, so I would, if I were just doing this one, I would shade this side. I'd shade above it. Okay, but I'm not going to do that yet because I'm not done. I still got to graph this quadratic, which was 4 minus x squared. A couple things I know about that quadratic. Y-intercept is right there at 4. Another thing was that it was a negative x squared. Okay, again, what I'm graphing right here is 4 minus x squared. So it opens down. Okay, it hasn't been stretched at all. all right, because it's negative 1 times x squared. And that means right here, okay, those points will be right there. Then I go 2 over and 4 down, there and there. There it's got x-intercepts at 2 and negative 2, okay? Essentially what this is we have a quadratic that has been flipped, so it opens down and shifted up 4 units. That's what we got here. Sketch in kind of roughly where it goes. I'm going to zoom back out again, and I made it solid because it's less than or equal to, and the less than sign means shade below. Okay? We're going to shade below. So I'm going to zoom back in again. And really you can use the vertex as a reference point for this. Go from the vertex and make an arrow draw, going down. Now it's got to be above the blue line and below the quadratic. Those would represent the points that are solutions. Okay, right there. Okay? So there's an example with a line and a quadratic. All right, seems like it'd be a little bit more complicated, but the same themes come up. Get your graph, and then shade above or below. That's really what it's about. All right, here's one more, I should say. Set of 2 inequalities. Notice we've got the interval here, and each one is just one variable. Okay, let's start with the x's. Let's take a look at these. If I zoom into my graph here, I want all the points that have an x value between negative 1, okay, the vertical line, x equals negative 1. It's right here. Okay, there's x equals negative 1. X equals 3. That's right over here. I'll mark these accordingly. That's x equals negative 1. That's x equals 3. Now this was an interval. This was an interval that was between negative 1 and 3. So I'm going to take the arrows, and they are going to point towards each other. Okay, they'll point towards each other. So if I was just graphing this interval, I'd shade right in between those two. And those would represent all the points on a coordinate grid that have an x value between negative 1 and 3. Now, the y value needs to be between 0 and 5, which is right up there. And again, these arrows need to point towards each other. Okay? Now you might have figured out by now that this area that kind of represents this rectangle, that represents my solutions. All the points that are solutions to both of the inequalities. The first one being x is greater than or equal to negative 1 and less than or equal to 3. And y is greater than or equal to 0, but less than or equal to 5. Okay, now I do want to take a minute here to illustrate the concept of a solution point. I've talked about that a lot and haven't actually done an example. Let's say we went in here and right there, okay, in red, I just pick an arbitrary point. Okay, that looks to be right around the coordinates 2, 3, that point that I marked. Okay, 2, 3. Again, what we're saying when we have a point that's a solution to both, that means I could take the x coordinate and substitute it in, and it would satisfy the inequality for both x and y. Okay, let's first look at x. If I put 2 in there, okay, it should make a statement that's true. All right, is 2 greater than or equal to negative 1 and less than or equal to 3? In other words, is it in between those two numbers? And it is. Okay? And that's because I marked with those vertical lines the boundaries of x equals -1 to x equals 3. Let's do the same thing with the y value. Is 3 between 0 and 5? Indeed it is. Okay, 3 is bigger than 0, but it is smaller than 5. All right? Any point that I pick from that little shaded rectangle that I have would satisfy both of those inequalities in that way. Okay, that it works for both. The same is true for the other two examples that I did. If you pick a point from your solution area, okay, the region that's shaded, it will satisfy both the inequalities because it was constructed in such a way that it would do so. Okay, we'll call it quits there. That's about, I think, all we need to see for now on doing a system of inequalities. Big theme here to remember: it's just like graphing one, but you do it twice. Okay, and you shade the area that works for both. All right, we'll leave it there, and we'll see you in class.